This section is about trigonometric integrals, when we have integral of trigonometric functions. So you know, Shabab, now from before, you know what is the integral. You should remember, ask yourself, what is the integral of sine, the integral of cosine, and the integral of tan, cotan, secant, cosecant, and of course the other issues related to the trigonometric functions. طبعا, you know, Shabab, when we have, for example, let me give you an easy one. An easy example about the trigonometric integrals. Cosine squared x sine x dx. Okay, let me take the most easier one. Sine squared x cosine. Now, when you have something like this, it is direct, Shabab. I think most of you, they know that if they put u equals to sine x, du will be cosine x. So this integral is just u du, u squared du. And this is, of course, u cubed over 3 plus c, which is, of course, sine cubed of x over 3. You can go directly from here to here, because it is clear. If you can do the substitution mentally, this is u squared, and this is du. So it will be sine to the power 3 over 3. Just be careful about if it is here cosine and sine, you have to consider the negative or positive signs. Now the question is, what you can do if you have here, for example, cosine to the power 3, if you have this integral, sine squared x cosine cubed x dx. What you can do about this? This is what we mean when we have a product of powers of sine and cosine. Now today we will have an answer for this question, how to do this integral. And the product of powers of tangent and secant for the same idea. Also, the same can be applied for cotangent and cosecant. And what else? By the way, this will be, of course, will depend in some way on this one. We will try to convert it to have du. So here the problem here, if we put u equals to sine x, we need du. Du will be cosine. So we will save a factor of cosine. We will see that together, inshallah. Let's start with the integral of cosine cubed x. You know what is the integral of cosine, Shabab? What is it? What is the integral of cosine squared? What is the integral of cosine, Shabab?
Minus sine.
Sine. Sine, not minus sine. Be careful, please, ya Shabab. I know, it is okay. You are mixing between the derivatives and the integrals. When you differentiate this, you must get this. So if you say negative sine x, when you differentiate, well, you will not get cosine. You will get negative cosine. Now, what is how to find the integral, Shabab, of cosine squared? Also, we will see today how to do this. But we did it before. We just write it as 1 plus cosine 2x over 2 dx, and you can continue after that. It is not difficult. Now the question is how to find cosine cubed. Any idea, Shabab?
By part.
We can do it by parts. Thank you. Yes, you can do it by parts, but there is a better idea. You can do it by parts, ya Shabab, as we did in the previous class, in general for n, but it is not easier than the method that we can use now.
We use u substitution.
But before using the u substitution, we need to do something.
We rewrite it to 1 minus sine square.
Exactly. No. First of all, we need to write it as cosine squared x cosine x dx. Why? We need here to get du. This will be du, ya Shabab. So we need to save a factor of cosine. So this is the first step. Look, ya Shabab. Now, if I'm gonna substitute, this will be du. So what will be u if this is du? U will be what? U will be sine x. Is that right? So we need to have here sine. We have cosine squared, and we know that cosine squared, it is just 1 minus sine squared. Now I can put this 1 minus u squared du. Very easy now. Look, it is all about u substitution. So if you put u equals to sine, then du will be cosine x dx, and you will have a very easy integral. It will be u minus u to the power 3 over 3 plus c. Now return back u to sine x, substitute back. So this the integral of cosine cubed, here it is.
دكتور
Yes.
ليه ما نستخدم طريقة اليو والدي في؟
This is what I said. You can use it. Why not? But it is not easier. This one is easier. You can use, of course, you can use, as we did in the previous class, you can use the integral by parts. But this one is easier. طبعا يا شباب, we should follow this order always. Is it direct? If it is direct, no need to any other techniques. Is it direct from the basic table of integrals? This is question number 1 that you should ask yourself. Question number 2, is it can be done by u substitution? If you can do it by u substitution, no need to use any other methods. If it is not working, ask yourself, can I integrate by parts? Then of course you can do here. Here we did it by u substitution. Just what is new here, that we use an identity. We use that cosine squared, it is 1 minus sine squared. And this is usually what we are going to do today. This is why we call them trigonometric integrals. We will use trigonometric identities. So always we will keep them in mind. Let's take another example. When we have sine to the power 5 of x times cosine squared of x dx, what we can do here, Shabab? Here also you should keep in mind that you need u and du. So what will be my u and what will be my du? What will be the substitution that I can use here? So keep in mind that we have between sine and cosine, this is the identity that I have. Sine squared equals to 1 minus cosine squared, or the opposite. So how can I use this? So to use this, ya shabab, you need what? You need the powers of cosine and the powers of sine to be what? To be even, to be able to use this. So what do you suggest here? What we can do here? What we should do here?
1 minus sine squared.
This one? But it will be more complicated.
دكتور
It will be sine to the power 7 in this case. We need to reduce the power, not to raise it. Yes,
ساين
here.
سكوير.
First of all, you should deal with this. You have even power here. So what you can do, you can
Sine
take
to the power
sine,
4.
ساين تايمز
you
ساين.
can write it as sine to the power 4 multiplied by sine. So this is the first step. Let me write it here, the first step. It is not clear here. So what you should write this as sine to the power 4x cosine squared x sine x dx. What I did, ya shabab, this is sine to the power 5. I just, you know that x to the power 5, it is equals to x to the power 4 times x. So this is what we did. And we keep this as a common factor, as a factor of du. This will be my du. So just I need to put u. If du is sine x, then u is what? Is cosine, of course, with negative here. So if we use u to be cosine x, du will be negative sine x dx. Okay, please ya shabab, who is opening his camera? Please close your cameras, ya shabab. Yes, Abdulaziz bin Ajayan, close your camera, Abdulaziz. Okay, because I cannot see clearly the names of who is speaking. Now let me I think you got the idea, Shabab. We need here to be able to use the Pythagorean identities. We need to have sine squared, sine to the power 4, sine to the power 6, even powers. So this is why when you have odd power, take one of the factors, one of the sine as a factor, and keep this factor for du if it is going to help you. Now here, because du is sine x dx, I should think about putting u equals to cosine. So I need this to be in terms of what, ya shabab? In terms of sine or in terms of cosine?
Cosine.
In terms of cosine. So this is why I will write sine to the power 4 as sine squared to the power 2. Here, inside this factor, I will write, instead of sine squared, I will write 1 minus cosine squared. Then I will expand. And you know how to expand. Or before expanding, it will be easier, I think, before expanding. But u equals to cosine, then du du will be in this case negative sign. Be careful about the derivatives and the integrals here. It is negative sine dx. We have this. Here it is. Just the negative, you can put it outside of the integral. So this negative, put it outside of the integral. And this will be 1 minus u squared all to the power 2 u squared. Now it is a matter of simplifying. This negative will go outside. This one will be expanded. It will be 1 minus 2u squared plus u to the power 4. Then multiplied by u squared, you will have u squared minus 2u. Now add 1 and divide by the new power. Now substitute back by cosine. This is the integral of, this is the value of this integral. We have found this integral. So I think now we are ready to summarize, let's say guidelines, how to, or a kind of strategy, how to evaluate integrals of sine to the power m cosine n. But by the way, I don't want you to just save this one or memorize it. You should deal with the situations like this. You should think about that when you have such example. You need to think about it in general. Indeed, you can also evaluate these integrals without this strategy. But this strategy, of course, can help you to figure out what you should do. Let's start, Shabab, here by thinking about when you have the integral of sine to the power m cosine to the power n. Now, if the powers of cosine, if the power of cosine is odd, so we have here like 3, 5, 7, and so on, then what we should do when we have here, we should save one cosine factor, like here what we did here with sine. In this example, if you remember, we were having sine to the power 5. The power of sine, it was odd. So what we did, we save a factor of sine. The same thing that you should do for cosine. When you have the power of cosine is odd, and you know that the odd number can be written as 2k plus 1. So you will take one cosine here. You will take one factor of cosine, and this will be your du, by the way, because you will choose u to be sine. You will use this. You will write it by the Pythagorean identity. You will write all of your integral in terms of sine, and this will be the derivative of sine. The idea is clear. If the power of cosine is odd, then save one cosine factor and use this identity to express the remaining factors in terms of sine. Is it clear? If you have odd power, convert the cosine to sine and save one factor. If the power of sine is odd, do the same, but this time for cosine. So what you will do if the power of sine is odd, you will save one sine factor and then use this identity, then express the remaining in terms of cosine. So this is the same idea that we did in the previous example. طبعا notice that if the powers of both sine and cosine are odd, you can use A or B. If both of them are odd, use A or B, it doesn't matter. Is it clear, Shabab, how to integrate sine to the power m, cosine to the power m? If both powers are even now, this is the case that we have only. We know what we will do if both are odd or one of them is odd. What about if both of them are even? If both of them are even, you need to use these identities, the double angle identities, or reducing the power identities. If you remember, the same as we did for the integral of sine squared dx and the integral of cosine squared dx previously. Also, sometimes you can use this. If you have sine x to the power x, for example, if you have sine squared, I will do that with you inshallah later. You have sine squared dx, cosine squared dx, how to integrate it. You can write it as sine x, cosine x all squared, and then you can use this identity. I think we are ready to take an example. More example indeed. Sine to the power 4. How to find the integral of sine to the power 4. This is good. This is just what I'm talking about now. So how to do this, Shabab? Any idea?
Sine squared all over squared.
You should write it as sine squared all squared. The same trick. Now this sine squared we can use. طبعا here it will not be useful, Shabab, to write 1 minus cosine squared. What is the benefit of that? we still have cosine to the power 4 when we expand. So it is not practical here to use the Pythagorean identity. So don't use this here. It will not help you, okay? Because if you having sine to the power 4, if you use it, you will have cosine to the power 4. So here we are thinking about reducing the power. So we will use this identity, Shabab. Here. This identity will reduce the power. It will not give me cosine squared. No, it will give me cosine to the power 1. Now expand, multiply. This a half will be outside. It will be 1/4. And this will be 1 minus this times 2 and cosine squared of 2x. Now it is very easy integral, Shabab. What is the integral of x? You can integrate 1. It is x. Here, the integral here. Okay, this is a good question. But before that, let me simplify this because I still have here cosine squared. How to integrate this? Any idea?
1 minus sine
No.
squared 2x.
We can
Oh, what is the benefit? The same question, how to integrate sine squared to x.
Doctor, we can use identity in the
Yes, you use this identity.
half times.
Use this one. But here you have 2x, here you will have 4x. So this is what we are going to do in the next step, I think. Yes. So we will delay the integration, just we will integrate at the end. Now, what is cosine squared to x? Cosine squared to x, using this identity, it is a half times 1 plus cosine the double of the angle. The angle here is 2x, the double will be 4x. Now simplify what is inside the Shabab. You have here 1 plus a half, it will be 3/2, minus 2 cosine to x plus a half of cosine for x. Now you know what is the integral of 3/2, it will be 3/2x. Here we will have 3/2x if we integrate. Here we will have what? What is the integral of cosine 2x dx? You know, Shabab, what is the integral of cosine x? The integral of cosine x is what? It is sine x.
Sine.
So here we have cosine 2x. So we will keep the factor of 2 by dividing by it. And it will be now sine 2x. So it will be sine 2x, but we divide by half. Why we divide by half? Because of the inner product here. Because the inner function here, its derivative, it is 2. So we will divide by 2. It is, you can use substitution, Shabab. You can put this equals to u, but I think no need because it is a trivial substitution. But you can use it if it is not clear for you. The same thing that you do here. So the integral here, the integral of cosine for x will be equals to 1/4, and the integral of cosine is sine for x. Who is writing in the chat? Speak up. Okay. Afik Abdul Aziz. For what? Now, what we need to do next is to just consider it as a final integral. So as I said, this is 3x. This is, of course, why we hear this, why this 2, where it has gone, we divide by this 2 that we have from the inner function. And here we will have 1/8 because we will divide also by 4. And this is the final integral. Now, I think we should start now, move to the next part of this section, how to integrate the product of tangent and secant. You know, Shabab, that these are the co-functions that we are talking about, usually sine and cosine. Usually tan and secant, they have, you know, let me ask you this question. What is the integral of tan? I think you know now, Shabab, what is the integral of tan. Who can tell me?
Secant squared.
Are you sure?
Then the absolute value of secant.
This is a common mistake, by the way. Be careful, Shabab. This is not the case. It is the opposite.
This is the derivative.
Yes, this is the derivative. It is not a problem, Shabab. Don't worry. All of us, we mixed up between them at the beginning, but after that, you will control this, I'm sure about that. So the integral of cosine, because what you need to remember, just what is the derivative of tan? What is the derivative of tan x? It is secant squared x. So because of that, the integral of secant x dx will be equals to tan x plus c. Okay, so what is the integral of secant of tan now, ya shabab?
ln
Ln the absolute
Sine.
value of secant.
Yes, yes, exactly. We did this before together. So it is the ln of the integral of secant x. You can write it also as negative ln cosine x, but usually we use this one, okay? So what I want you to recall is this. Be careful, don't mix up between them. Now, so this is why we usually have them together, because they are related in some way. They are derivative of each other, integral of each other, and so on. And also, most importantly, we have a relationship between them, the Pythagorean function, ya shabab. Do you remember that 1 plus tan squared x equals what? Secant squared x. So this is the most important relation that you are going to use here. So what do you think, ya shabab? What is the strategy here? Who can give me an idea about how to find this integral? What is the factor that we should save here? What is the factor that we need to take it as du?
secant square.
Yes, ya Abdul Malik, Ahsan, secant squared. Because we know that the derivative, if I put u equals to tan x, what will be du? Secant squared x dx. So I should keep in mind that it is good if I have this inside this integral. I don't have it here, but it is not difficult. I can write this secant to the power 4 as secant squared secant squared. This is exactly what we are going to do. So I will write this sine secant to the power 4 as secant squared. Now I will keep this as du. This will be the derivative of u. In this case, this means that u is what? U is tan x. So here I need to write this in terms of tan only. I need to write my integrand in terms of tan. How to write it in terms of tangent, ya shabab? We will use the identity that I have just erased. 1 plus tan squared x equals to secant squared x. So now secant squared x, I will write it as 1 plus tan squared. Here we are. This is secant squared. Now I will put u equals to tan x, then du as secant squared. So this will be du, and this will be u. So it will be u to the power 6 multiplied by 1 plus u squared du. This is du. Now it is so easy integral. Just expand. It will be u to the power 6 plus u to the power 8. Add 1 and divide by the new power. Substitute back. This is your integral. I think we need a strategy similar to the one that we had for sine and cosine. So let's set up the strategy of evaluating such integrals. Now it depends, are they odd or even, the powers of tan and secant? Now if the power of secant is even, so if we have here even, like the previous example, if you remember, what we will do, we will save a factor of secant squared, and this will be my du. Then I will write the remaining expression in terms of tan, as we did in the previous example. So the plan is here. If the power of secant is even, save secant squared as a factor for du, and then convert this to tangent, and you use this substitution after that. Now, if the power of tan is even, not the power, if the power of tan is odd, because I will talk about the next case in the next slide. So now, if the power of tangent is odd, what we should do? Now here we need to recall something here, because if the power, ya shabab, of tan is odd, like tan to the power 3, here, for example, secant squared x, it is not a problem, because this will be u to the power 3 du. It is not difficult. And this will be the first case, by the way. But here we are talking about if the power of tangent is odd, and maybe also this one is odd. Okay? Whatever, if this is odd or even, it doesn't matter here. But even when the power of secant is even, this is case number A. If the power of tan is odd, regardless of the powers of secant, What we should do here, we should save a factor of secant and tan. So we will take one factor from secant, one factor from tangent. And then we will express tan in terms of secant. And then we will use this substitution. U equals to secant. And you know, ya shabab, when U equals to secant, what is du? Du will be secant x, tan x, dx. So this is why we save a factor of secant and tan. Let me repeat that again. If the powers of tan is odd, take one tan from here, and you will left, this is one tan, and take also one secant from here. And this is what is going to be your du. Now, what is remaining here, write it in terms of secant. So you need to write, instead of tan squared, you need to write tan squared equals to secant squared and minus 1. So here you will replace tan squared by secant squared minus 1. Now we have a function here in terms of secant. So you will put your u equals to secant x. And then the u will be this. طبعا if the powers now, if there is no secant, which means that it is secant to the power 0. So this is the same, but here it is 0, no secant. What we have this case when when there are no secant factor and the powers of tangent is even. Now we discussed before it is odd, here when it is even and positive. And here you need to convert the tangent squared factor to secant squared factor, like here. So we have here tan to the power m. M here, m is even. What we will do, we will write it as tan to the power m minus 1 tan squared. So we saved the factor of tangent squared. Here it is. Now this one, I will write it as secant squared minus 1. Then I will distribute. The next step, I think it is not written here. It will be tan to the power m minus 2x dx minus multiplied by secant. You will distribute, this will be multiplied by secant squared x dx minus the integral of tan to the power m minus 2x dx. And this will be less than the original integral by 2. You can keep doing this until you can integrate. Here it is so easy. Here you will put u to the power m minus 2, and this will be du. It is not difficult. And the last case I think that we should have when we have only secant. So when the power of tan is 0 and we have the power of secant is odd. In the case of even, we have mentioned it before. In A, it was part A. If we have secant to the power n and n is odd and positive, of course, here we need to use integration by parts. Do you remember this example from section 7.1? Secant to the power x dx. How we integrate this? We did it by parts. It is the best way to apply for this. We will repeat it today, inshallah. What else? When the first 4 guidelines, this is from A to D, don't apply, when they cannot help you, then try converting to sine and cosine. And this is, of course, not always works, but if you are not able to deal with them with the previous 4 guidelines, then try converting to sine and cosine. What we did here, ya shabab, for tangent and cotangent can be applied similarly for cotangent and cosecant, because you know they have the same relation. You know that 1 plus cotan squared x equals to cosecant squared x. What you need to be careful here, that the derivatives. What is the derivative of cotan? The derivative of cotangent x, it is negative cosecant x. So here you have negative. You have to be careful about the negative in the case of cotan and cosecant. Example. Find the integral of tan to the power 5 secant to the power 7. Now, you can recall this, ya shabab. You can recall this strategy. What should I do? What should I do? You can revise them, okay? But in my opinion, you can solve it without this strategy. But you have to be careful. This will come from the practice. Now, what do you think now? What is your plan? Are you going to write your integrals in terms of tan and you will put tan u equals to tan, or you will put u equals to secant? If you want to put u equals to tan, then you must have du equals to secant squared x. If you want to put u equals to secant, you must have du equals to secant x tan x. So what is your plan, ya shabab, here?
U equals secant.
U equals secant.
U equals to this. Why? Because ya shabab, both of them are even. Both of them are odd. If you notice that, if I save one factor from secant and one factor from tan, I will have secant tan. So it will be the second case. So because ya shabab, it is the best case when we have these powers even, not odd. So here, this is even, this is even. Now this is my du. This will be my du, and this tells me to choose u as secant theta. So here we need to write tangent to the power 4 in terms of secant. So what I will use the identity that says that tan squared, because this will be tan squared of theta all to the power 2, because it is tan to the power 4. Now tan squared, it is just secant squared theta minus 1, all squared. Now this is secant to the power 6. This is my du. I will keep it. Now this will be my u. I will put u equals to secant squared. I didn't mention it here. I think it's clear. Yes. This is just u squared minus 1, u to the power 6, and this is du, because if you put u equals to secant, du will be secant theta tan theta. Done. You integrate now. Taban, you can recall, you can go back and say which case I will use here. Which one? Let's recall here. If the secant is even, it is not this case. If the power of tan is odd, it is this case. Look, we will have it like this. So it was when the tangent is odd. But notice that we were able to integrate without going back to the strategy. So this is why I call it, shabab, just guidelines. It could help you, but it is not the only way that you can do. You can, of course, use your experience in integration, differentiation, and the identities that you have between tan and secant. Good. Now you will just expand here. So this is just u to the power 4, and then it will be multiplied by u to the power 6. It will be u to the power 10. Expand, it will be negative 2u squared multiplied by u to the power 6. It will be, we did here 2 steps in 1 step. Divide by the new power, add 1, and divide by the new power. Return it back. And this is the integral. It is in terms of secant. Now, I asked you this question at the beginning. What is the integral of tangent of x? It is ln, the absolute value of secant x. Similarly, the integral of cotangent, shabab, is ln sine, or you can write it as negative ln cosecant. It's okay, but let's keep the positive one. Now, it is natural, shabab, to ask yourself, what is the integral of secant? Who can tell me? What is the integral of secant x? Did you ask this yourself this question before? What is the function? What is the function that its derivative is secant?
Root of tan x.
Doctor, ln
Root of tan.
Root of tan? This is strange. How this, if this is the function, is the derivative here is secant? What you are doing?
Because the tan, his derivative of tan, secant squared.
So what does that mean? If your function is tan x, then the derivative, it is secant squared. Is this means that if the function is secant x, then the derivative is square root of tan? This is not the right conclusion. Be careful. Be careful. This is not the situation at all. I will prove it for you. Yalla, differentiate. Yeah, who said that? I think he is Mu'ad. Yalla, ya Mu'ad, differentiate this. Find the derivative of this. Find the derivative of this function. Yalla. Come on, ya Mu'ad. Yalla, why you are loving? Differentiate. It will be 2 times tan squared. You forget how to apply the chain rule.
Oh,
And the
children.
derivative of tan is, yes, how to differentiate. Now, is this equals to secant? It is
I
not.
think not.
It is not.
Yes.
It is not. Be careful, ya shabab, about these conclusions. Be careful. It is mathematics. Yes. Who knows, ya shabab? Anyone, or I should state? Now, let's assume that we don't know what is it. And until now, I didn't tell you before what is it. But you should ask yourself this question, ya shabab, always. Because you have six trigonometric functions: sine, cosine, tangent, cotangent, secant, and cosecant. You should ask yourself, what are the integrals of these functions? Okay. So now there is a nice trick here how to find this integral. It is in fact not. I don't think that it will come easy to your mind, but there is a nice trick. Is there a problem if I multiply secant by 1? Is the value going to be changed? No. The value of the integral will stay the same. But what is the best one that I can use here? I need to use something over something else. What I'm going to use?
10/10?
No. I will use, ya shabab, the secant x tan x over secant x tan x. Why this one? Why especially this one? You will see that in a minute. So I just multiply by 1, but not any one, a hero one. My hero here is secant x tan over secant x plus tan. Secant x plus tan. Now look what I will have in the numerator. And what I will have in the denominator. Now, this is why I did multiply by this specific factors, or by this specific fraction. Now, ya shabab, if I put u equals to the quantity in the denominator, if I put u equals to this, what will be du? It will be secant squared x. The derivative of secant is what? Secant x tan x plus what is the derivative of tan? Secant squared x dx. What is this? It is the quantity in the denominator. In the numerator. It is the quantity, the same quantity in the numerator. Do you notice that?
Exactly the same.
So what is the integral? If you have here a function and you have here the derivative of this function, when you integrate, what will be the result?
ln.
It will be ln. It will be the logarithm, the natural logarithm of the absolute value of f of x. Yeah, shabab, you didn't add this to your table of integrations. I told you to do. This is a generalization when you have here 1, when you have here x. It is the same. The integral of 1 over x dx, it is ln the absolute value of x. Here you have x, here you have the derivative of x. And here you have the x. Okay, so it is better, ya shabab, to write it 1 over u du. I advise you to don't use x, because most of you, they stuck with x and they cannot think about other issues. So when you have 1 over u du, so when you have du over u, when you have u du, so this is u, this is du. Now, according to this, if we put u equals, this is 1 over u, and this is just 1 over u du. When we put u equals to secant and du equals to secant tan secant squared. Now, what will be the integral? The integral will be ln the absolute value of u. And what is the integral? The u is secant, substitute back. What we conclude from this, that the integral of secant x is ln the absolute value of secant x tan x. We have a new integral that you need to add to your table of integrations. Use this, ya shabab, basic integral now. No need to do this every time. You don't need to do this. Just recall this. The integral of secant x dx is ln the absolute value of secant x plus tan x. Add it to your table. Update your table. Not only this one. Similarly, if you want to find the integral of cosecant, I think you have the same idea. What you will be multiplied by, ya shabab? We will multiply by what?
Cosecant x.
Cosecant x minus cotan x. Why especially this factor? because you need to have the derivatives. So it will be like this. This is the integral. Try to do the same, apply the same idea, and you will have also the integral of cosecant x dx will be ln cosecant minus cotan x dx. Also now update your table of integration by adding these two integrals. Why I mentioned them here, because by the way, we should mention this early, by the way. This is I think I should mention it in 5.5, but it's okay. Now let's apply them for this integral. Find the integral of tan to the power 3 x dx. How to find this integral? I think it is natural to think about saving one factor of tan. So you will use this identity, and to use this identity, you need the power of tan to be even, not odd. So you will just write this as tan squared. Then this tan squared, you will replace it by secant squared minus 1. So your integral will be like this. Tan x secant squared minus x. Now expand, this will be tan multiplied by this, tan multiplied by this. So you will have two integrals like this. Now here, this integral is easy, ya shabab. Am I right? Why this integral is easy? Because here you have what? The integral of what?
U du.
U du. This is u, and this is du. So this is just u squared over 2. So this is just tan squared x over 2. For this one, it is what? Ln secant x. It is direct one الآن. After studying this, it is direct. So now if you mentally substitute u equals to tan, and then the du will be this, you will have tan squared over 2, and the integral of tan is ln secant. And this is our integral. So easy. So where was the most important step? Is this step, the first steps that you think about having even power of tan. Then use this identity. Let's take one example before we end this class. Yes, the integral of secant to the power 3. Now this is the one that I told you about here, Shabab. Do you remember what we said about when we have the power of we have integral of secant, and the power is odd. You have integral like this. How you should integrate this? You should integrate it by parts. Always, ya shabab. It is mentioned in the strategy. Recall the last part in the strategy. Now here what we will do, we will just write it as secant squared. Always we should have, ya shabab, powers like this. Now we need to think about any way, shabab. Here, if you think about the u substitution, it will not help you. Because in the u substitution, you should have tan inside if you want to use a substitution. But here we don't. So what we should do, we should choose one factor to be u, another factor to be dv. What do you think? What we should bot u and what should we bot dv? If we bot u equals to secant, I know what is du. It is secant x tan x. Am I right? If I bot dv equals to secant squared x dx, I know what will be v. It is tan. The integral of secant is tan. So this is the best case. If you did the opposite, it will not be easier, shabab, because the derivative of secant, it will be 2 secant tan, and the integral of tan is the integral of secant. The integral of secant, it is complicated. It is ln, the absolute value of the sum of secant and tan. So don't use dv. Don't use dv equals to secant x, because v in this case will be ln, the absolute value, and this is bad. This is bad integral that will complicate your problem. Unfortunately, the time is up, shabab, and we will continue this last time. I think this is the last example in this section. If am I right? No, we still have. No problem. We will continue tomorrow, inshallah. Thank you, shabab, and see you, inshallah, on tomorrow, inshallah. We will continue tomorrow this section, and we will start 7.3.